Hi everyone, I just want to take a moment to go over how to do scientific notation. With this handout here, which you could find posted on Google Classroom, you can see here that we're starting off with a number, a typical number like you would see, 2.8, but here it says times 10 to the 8th. This is what makes it scientific notation. The whole idea is we can take really, really big numbers with lots of zeros in it and shrink them down into something smaller. The two are known as regular notation. That's how we normally write numbers, and scientific notation, the way that we write the numbers with this multiplied by 10 to an exponent. Now, really comes down to which direction are you going to be moving the decimal. So if you remember from today's lesson, if the decimal is moved to the left, the exponent will be positive. If you move the decimal to the right, it will be negative. So let's do a couple practice questions on here. It says here, change from regular notation to scientific notation. We're starting off with a number 45,000. Well, 45,000, we know, has a few non-zero digits in it, the 4 and the 5. And the formatting of this means that we're always going to have one digit, a decimal, and then a few other digits, or in this case, just one other digit after that. We're going to say multiplied by 10, and we have to figure out what the exponent is. So right now, I know that there is a decimal hiding right there. Zoom in a bit. And if that decimal is hiding right there, and I got to get it between the 4 and the 5, I'll be moving it over 1, 2, 3, 4 spots to the left. So in this case, it would be 4.5 times 10 to the 4th. Now, since we're moving it to the left, we know that that number is going to be a positive number. It's going to be greater than 1. If we had it smaller than 1, like 0 point something, it would be a negative exponent. We'll try a couple more. Here we have the number 9,000,000, 9.0. We have to have a 0 or a digit after that decimal to make this work. So I'm just going to take the first one there. Now I know that the decimal should be between the 9 and the 0. I'm going to move it from where it currently is, 1, 2, 3, 4, 5, 6 times to the left, making it 9 times 10 to the 6th. If we go with a small number, like this one, 0.00000378, we know that the exponent is going to be negative in this case. So let's take a look. In this case, I'm going to write down 378. Any of my non-zero digits, and I'm going to move my decimal over 1, 2, 3, 4, 5 times 10 to the negative 5th. That would be 3.78 times 10 to the negative 5th. Let's take a look at number 6. Number 6 is a little sneaky. You see here we've got a 0, but then we have a 4. That means we need to include that. So in this case, it would be 6.704 times 10 to the what? Well, move our decimal over 1, 2, 3, 4, 5 times. Why is it positive? Because this number is greater than 1. And then we can do the other side here, where we have a couple that are already in scientific notation and we have to convert back. Now, I'm looking at this one where it's 9.46 times 10 to the negative 6th. I know that my number is going to be very small. So I'm going to start by taking my non-zero digits and I'm going to put them all the way to the right, 946, and I'm going to move my decimal over 1, 2, 3, 4, 5, 6 times. Backfill all the zeros that belong there, and you could even add a leading 0 after it, doesn't matter. But our answer would be 0.000000946. All right. One last one, and we'll call it a day. 4 times 10 to the 5th. 4, and we're moving it over 5 times. I know the decimal is currently right here, and I'm going to move it over 1, 2, 3, 4, 5. Back, fill your zeros. Our answer would be 400,000. Hope that was helpful.